Hi everyone, we're on chapter 9 now for statistics describing data. It's page 97 of your workbook. You'll want to have a ruler or straight edge, just anything with a straight edge handy, and a calculator. So again, read through your book carefully. This book does some things just a little bit differently than other textbooks I've used for statistics. So especially when we're talking about histograms. So I'm going to try to go along with this book. However, you will even see maybe in the answers some inconsistencies on things. So if you're not sure of something, let me know. Making a histogram and a frequency table and then a histogram from it, or a frequency polygon of that sort, you can kind of adapt the numbers. There is a formula to try to figure out how big your intervals should be and things, but you can kind of make it fit nicely. Like if you get a number like 8, it's not going to sit really nice. So you kind of want to look for numbers that work well, like 5s or 10s or things like that. You'll see what I mean when we get there, but just keep that in mind. Just wanted to say that in case I forget later. So here, frequency tables, they have 2 columns. There'll be a category and then there'll be a frequency. Relative frequencies are when we're taking the either a fraction, a reduced fraction, or decimal or percent. So make sure you label that. Make sure you always put titles on things. That's really important. So here we just have a very simple one to start out with. This is some qualitative type data, but that we're getting numbers from. So we're seeing what the frequencies are. So you can crunch numbers and figure out some percentages or averages with qualitative data. This is an example of doing that. So if we have all these colors, this would be on maybe a survey or something you were doing an experiment with, and maybe it was some kind of spinner and people were spinning and got a certain color. So construct a frequency table for the given data. So it's just a chart that you're going to make, and I'll show you how to do the tally method also on a bigger problem with more data, but this one is just really pretty small, so we can just count them out. So we want to put here, it's a frequency table of color data. I don't really know what it is, it's just kind of generic. So then I would write color, and then I would put frequency here. And if it does say include relative frequency, so we'll add a column for that so we don't forget. Now this one, I don't really need my straight edge so much, it's fine, but when you're doing the graphs, you probably want that. You might even want to use graph paper. So here I have blue. You can just use first letters too, but green, and I have red are my colors. And then I might want to figure out the total also. I'm going to put a double line there. So I'm going to go all the way across. So for blue, we can just count up the blue. So go ahead and do that. Count these up. You can pause the video. You can then come back and check. For relative frequency, what you're going to want to do is you're going to want to take the number you found for the frequency and divide it by the total. Okay, so we have, if you count them up, 14 total data values, and for instance blue, if I count up all my blue, I get 5, and then the relative frequency would be 5 over 14, and I could write that as a reduced fraction, which it is, or I could write it as a decimal which I get 0.357, so on and so forth. So I could just write it as 0.357, or I could write it as 35.7%. And this is really approximately, we don't need to worry too much about that, but just so you know, we are rounding. So go ahead and stop the video and I will finish this up while you're working on that. Okay, so here's all our answers. There were 4 green, 5 red. So here's the percentages is what I focused on. You could, again, write it as reduced fractions also. If you totaled all those up, you would get 1, or you would get 100%. 1 and 100% are the same thing. So let's go on to the next page here. Looking at bar graphs. Bar graphs are just kind of like line, like instead of drawing a dot and then connecting lines together, we just figure out how high it is and draw a bar. We don't connect the bars together. We don't put them next to each other right close together like we do in a histogram. So here is the definition for a bar graph. There's going to be a vertical axis, and we want to use that same data that we used in the previous example for the color. So we're going to just draw a little grid here. It doesn't say it wants relative frequencies for this, but we could use either unless it specifies. I'm going to do actual frequency on this one. But do pay attention to that if a question asks for relative frequency. I don't really need a lot of room for this, but my numbers are pretty small. The thing to note is that you want to write frequency, like I could just turn it like this and know that that represents frequency rather than relative frequency. I also want to put a title here, bar graph of color data. And then we also want to write our colors down here and label that axis. Okay, so the horizontal and vertical are both labeled. So then we would just write blue here. You can just put the word right in there, space them out evenly. Green and red. And then here's where I might want to use the ruler, but I do want to make like kind of equidistant tick marks. I'm just going to do 1 unit because I don't have a very high value there. So blue I know was 5, so the frequency is 5, so I'm going to kind of just draw a little line across there. So I'm just going to track it. I know usually I put like a little 5 up there. Green was 4, so you can use your straight edge here to help you kind of gauge where to put that. And then red was 5. And then make them about the same size. Again, it doesn't need to be perfect. You can use a computer to generate this stuff as well in Excel, but I don't even think we're going to get that far into it. So I can post some videos that I made for my stats class if you're interested in that. So these really should be equidistant as much as possible. Sometimes people shade in the bars, but it's not necessary, but you can. It looks a little nicer. Okay, if you've taken a stats class, you might have used StatCrunch before or Excel. I like Excel. So you can use it anywhere, and you do get that with the Office 365. So a Pareto chart on the next question is all you're going to do is the same thing, except for you are going from highest to lowest. Now, some textbooks will always have those then touch, even though it's not a histogram, but this textbook doesn't look like it does, so we will just do it the way they would like. So I'm going to leave that one as a classwork for you. And also the pie chart on the next page. To create a pie chart, see if you can figure that out. It does not need to be perfect, but try to judge the best you can. I will say use the relative frequency. It helps you find the size better. And so I'll go ahead and fill those in, and then we'll take a look at that pictogram as well. Okay, so here's my graph of the Pareto chart of color data. Well, chart, graph, same thing on this one. So it would be blue and red are the same. So I could put the numbers there. Some people really require that all the time. Make sure you label your axes. Simple as that. This one, the pie chart, just do your best. I mean, obviously, I didn't use a compass or anything, but that's fine. You can, if you have a circle shape, you can use that if you like. But what I tried to do is just keep these to the same size, the blue and the red. Not looking too perfect, but the green should be just a little bit smaller. And again, it doesn't have to be, perfect. Just want you to see the difference. So you do want to write the percentages in there. When you're doing your homework, a lot of times you're just going to be choosing things from option A, B, or C. Here's the pictogram, just to talk about this. Sometimes people really love to use these things, but you can see here where it looks a little bit, it's hard to maintain the shape when we're talking about volume, and we did some of that in the problem solving unit and noticed how you really couldn't compare like a diameter to the volume of something. It really didn't work out the same way. And so the pitfalls of these are they often look distorted, they can cause distractions, but a lot of times people want that to happen if they're marketing something in a certain way, and they'll use a pictograph. So use your common sense to know that, if I see a pictograph, it might not be the best way of looking at the data. So now this next one here, one thing I want to point out too with my little circle graph here, what I did was figure out the percentages, and then I did round off, but I think I adjusted it. So I made sure, even though this should have really technically rounded up to 29, I would either have to go out like another place to make things add up, but you always want to have it add up to 100%. So in order to make that happen, I just rounded down instead on that one. So if you had a little bit different rounding than I did, that's why. So now on this next one, that's the point we're bringing up. This looks like an oval here from this document camera, but it is a circle. And so you can look here at this, the relative frequencies, and it's deliberately incorrect. So find the inaccuracies. There are a couple that I can notice right away. You might be able to notice that. So look at that as a classwork, and then I'll just go over the answer real quick. And then the same here on this one. Just tell me the two charts have the same data, but the difference seems larger for the graph on the left. Just tell me why you think that is, and then we'll talk about it. Okay, so here are the answers now for the classwork. What I found, I'm sure you could find some different things as well, but blue and green have the same percentage written. They're both supposed to be 25%, but they're clearly different sizes. Also, if I add up all the percentages, it only adds up to 93%, and it should be 100%. So this other one here, if we look at the scale, the vertical scale on this one is different than on this one on the right. So always note your scale and check that out and make sure things are matching up. So it looks like, this one kind of looks like there's, bigger increase. It's a lot taller, but it's really the exact same if you look at the proportions there. So I am going to pull in a PowerPoint real quick just to show you a few other things, and then I'll do another video for the next section. Okay, so just real quick here, graphs that enlighten and graphs that deceive. This is from the Triola curriculum. So some graphs are really great and help us, but some are intentionally misguiding us. So here's a dot plot. It's quantitative data. It's really kind of a nice little picture. We might work with that a little bit. So it's very easy to see, but it is kind of a pain to make the dots rather than a bar if you are doing it by hand, but it is kind of a way to track as you go. So you're kind of tallying and making your graph all at the same time. This is a stem or stem and leaf plot. Your whatever place value is furthest out. So that's the tens place here. And then this would say, well, I have two data values, one of 40 and one of 42. I have a lot in the 50s. I have a ton in the 60s. So I can see, not only see how it lays out, but I can actually see what the values are. So that's kind of nice. Stem plots show the shape, retain original data values, and it's also sorted, which is nice. This is a time series graph. We don't really do too much of that, but you might see those. Time series graph reveals info about trends over time. Bar graphs are used for categorical or qualitative. We have small gaps in between. We've done one of those. Pareto has descending order. Here's a Pareto chart. We did one similar. Pie charts. It's the same data in a pie chart. Frequency polygons, we may or may not hit in this curriculum. It's like a histogram. We use it for quantitative data. Looks like this, and you use the midpoint of the data to plot your dot, and then you do actually connect. But again, you're seeing, a title. The title is down here in this case, and here is the horizontal axis label. Here's the vertical axis label. It's usually just frequency. Sometimes we like to lay two on top of another so we can compare. Graphs that deceive non-zero vertical axis. This is kind of similar to what we were looking at before, but it's a percentage, so it should be the same, except for this one starts at 10%, not 0. So it looks like this is a lot bigger gap. Pictographs we talked about. And remember, when we double a side of a square, its area doesn't merely double, it increases by a factor of 4, and so on and so forth. And with volume, it would increase by a factor of 8. So this looks a lot different. So some are useful, but again, we need to have things that are not just kind of look good, we need to have them be accurate. So here's some rules of thumb. For small data sets, 20 values or fewer, use a table instead of a graph because you can just look at it and see. A graph should make us focus on the true nature, not just be eye-catching. Don't distort the data. Make sure you start at 0, or if you don't, put a break in it, a clear break that shows that you didn't. Almost all of the ink in the graph should be used for the data, not for other design elements. And that is it. I'll put that back. So let me know if you have any questions on this, and I'll take up with another video on the other sections.